So now we're going to talk about a function being one-to-one or injective. So we're going to start with the definition. A function f from a to b is called one-to-one or injective. Those terms are used interchangeably if every two distinct elements of A have distinct images in B. So the formal way to write this is to say that f from A to B is one-to-one if whenever x and y is in A and x is not equal to y, then f of x is not equal to f of y. So two distinct elements of A, which is what we mean when we say x is not equal to y, have distinct images. So f of x and f of y are not the same. Now, it's not that easy to work with things being not equal. And so really what we should do, it's easier, say, no, it is easier to work with the contrapositive of this statement. And remember that a statement and its contrapositive are equivalent. And so really, we're going to take the contrapositive of this last part right here. So we're going to say a function f from A to B is one-to-one or injective, either one, one-to-one, if, so the contrapositive would be if, whenever f of x equals f of y, where x and y are in A, then x equals y. So what's nice about taking the contrapositive is that it got rid of those not equal things. It's harder to show things are not equal. It's easier to show that they are equal. So this is easier to work with, and this is usually what people use as the definition of one-to-one. So let's look at some examples here where I want to either prove or determine that a function's one-to-one. So let's say prove the function f from R to R defined by f of x equals 3x minus 5 is one-to-one. So when we write our proof here, we're going to start by assuming or supposing that f, here I'm not going to go with x and y, I'll go with a and b. Assume f of a equals f of b, where here my domain is the real numbers, so where a and B are an R, well, that means that 3A minus 5 equals 3B minus 5. If we add 5 to both sides of our equation, we get 3A equals 3B. Now here, because I'm talking about real numbers and not integers, I can divide. So we can divide, dividing by 3, we get A equals B. And that's what we needed to reach. If you look back at our definition, we needed to conclude that A was equal to B. Therefore, F is 1 to 1. And that's the end of my proof. Let's look at one more of these. So for example, let's let the function f from R to R be defined by f of x equals x squared minus 3x minus 2. Determine whether f is 1 to 1. Well, here, if I think about my function, it's a parabola, right? Here, this is a parabola. So my guess is that this function is not 1 to 1. And so, for example, let's see, if I plug in 0 into my function, it outputs -2. And so the question is there a different value where I plug in it for x and I also get back -2? So let's just say this equation equals -2, and we want to solve here for x. So there are two values, x equals 0 and x equals 3. So if I plug in 3, it'll also spit out -2. So here, my answer is going to be, let's say answer, f is not 1 to 1. And to justify your answer here, you're saying it's not 1 to 1. You don't give a proof. You're going to find a counterexample. So here, if I plug in 0 into f, I get -2. And if I plug in 3 into f, I also get -2. But these inputs aren't the same. 0 and 3 are not the same. So there's my, again, what you needed to do is give a counterexample. So the last thing in this video I want to mention is that kind of what the visual idea of 1 to 1 means. So remember when we were using these diagrams, A to B. So this last function, for example, it was not 1 to 1. Because 0 mapped to -2 and 3 also went in to -2. So you can't have two arrows coming in to a single element here. That's the problem, is that if I look at -2, I have two arrows coming in. So that can't happen if you want your function to be 1 to 1 or injective.